And I forgot to mention the bottom of the plate is supposed to be insulated. Okay. So let's say the bottom is insulated. Y is equal to 0. Y is equal to 10 millimeters. Temperature at the top surface, T at Y is equal to 10 mm is 75 degrees Celsius. Q dot is non-zero. And I know that at the top surface there is convective heat flux. So I'm going to draw a control volume, and I have the following entries. I have Q double prime convection given to me, 420 watts per meter square, taking place over the surface area of the plate. I have the volumetric energy generation. The bottom is insulated. Energy balance tells me that the following equation is going to hold true. And now I'm going to erase this particular part. E dot in, E dot out, E dot generated is E dot stored. This is your basic equation. E dot stored is 0. Steady state. Yes, question.
I'm the intervals looking back. 0.453, does that disappear?
Oh yes, that's also true. Yeah, I need to do that. Thank you. Yeah, I'll be posting my overall solutions where all these will be taken care of. Okay. Thank you for pointing it out. E dot stored is 0. Steady state. There is no E dot n in this problem. E dot out is the convective heat transfer coefficient flux, convective heat flux multiplied by the surface area. So this is Q double prime convection multiplied by the area. This is equal to E dot G, which is Q dot, times the volume, which is the surface area times the thickness. Where T is the thickness. Surface area cancels out, so that I have Q dot is Q dot convection by the thickness, and that's 420, 10 millimeters, which is 42 kilowatts per meter cube. This is now going back to the beginning of the semester, right, where you did this energy balance, you calculate P Q convection and Q conduction and so on. And then the last step in this problem, I have 1 more minute left. I'm just going to write out the steps. I need to calculate the temperature distribution through the thickness of the plate. What do? You bring in your good old heat diffusion equation. Okay? So this is going to be K of the plate, d square T. Instead of X you have Y. One-dimensional heat diffusion equation plus Q dot is rho C dt by dt, which is 0. So that becomes a quadratic, which you have solved for in multiple places in your exams and in your homework. So we will skip all the details. This is minus Q dot y square by 2 K plate plus C1y C2. I need two boundary conditions for C1 and C2. And I have two boundary conditions. Temperature at the surface of the plate, y is equal to 10 millimeters is 75 degrees, which is why we calculated that fellow in the first place. Then I say that the bottom is insulated, so dt by dy is 0. Okay? So in this case, dt by dy is 0, and T at is 75 degrees. These are the boundary conditions. Substitute, obtain C1 and C2. C1 ends up being 0, C2 ends up being 82 degrees Celsius. And we have a quadratic profile. Okay, thank you.